So somebody asked about part B, but let's quickly go over part A. We're given the f prime of x, or dy dx, and we're asked to solve for y with some given conditions. So to solve for y, the first thing we'll do is a separation of variables. We'll multiply both sides by dx. Now we have all x's in dx, all y's in dy, and we do the integral of both sides. We have y equals, and this is the -3 natural log of x minus 2 plus x squared over 2 plus c, and so now we just have to find c, and for that we'll use the initial conditions. So when x is 3, y is 4, and down 1 is 0, so we have c is -1/2, and there's part A. We've solved this differential equation, this diffie-q. All right, but onward to the question at hand, part B, which said for your solution in part A, find the limit as x approaches infinity. Well, if we take the limit as x approaches infinity, we can see that this term is approaching -3 times the natural log of the absolute value of infinity. We know that the natural log curve does approach infinity, so -3 times infinity. This is approaching -3 times infinity, or we can say negative infinity. But it's growing kind of slowly. Now we can triple that, and it's negative, but it's still, its rate of growth is pretty slow, versus this part of the function is x squared, and as x approaches infinity, x squared is approaching really big numbers. It's approaching, like a parabola, which as x goes to the right, it's growing fast. And so this positive infinity, it's growing toward positive infinity a lot faster than this expression, which is going towards negative infinity, is getting there. This is getting to infinity a lot faster than this is getting to negative infinity. Therefore, overall, this expression is unbounded, which is to say, as x approaches infinity, so does y.